Alrighty, so welcome back. Welcome to those of you who are here on campus for the first time in over a year, and welcome to those at home. Awesome. All right. Today we're going to be doing some examples and practice of section 10.2. Right, that is comparing to population or group means. Yesterday we looked at proportions. Today we're going to do means. Slightly different than yesterday. I'm going to do an example first. I'm going to go kind of walk you guys through an example problem that shows confidence interval, significance test, doing some of the different calculations. And then you guys will have an opportunity to do a problem as well. Considering how things go, first period, that brought us to about an hour, maybe because I'm terribly long-winded and maybe because we just needed that much time, who knows. So we'll find out. But that's the basic idea for today. And again, I'm trying some different tools and ideas to try to make this a little more normal-ish for people who are in person. Hopefully all those things cooperate. So we'll find out. So I'm going to, let's see, how do I want this to work? That's what I have to do. Okay, so I'm going to share my screen from here, which will first be the example problem that we're going to look through. So this should be a shared screen right here. So hopefully you guys are now actually looking at OneNote. And then what I'm going to do is take this guy, put it here. That's not terribly big. That's not what I was hoping for. Let's try something else. One moment, please. Try this. No, it doesn't give me that option. Dang it. We're going to do this slightly differently then, because that didn't do what I wanted it to do. One moment. And why is that still up there? Oh, where I go? Where's my mouse? I want to, no, I want that over here. And that goes here, that goes there, this goes there. Ha. All right, that's easier for you guys to see here in person. And then, what have I done wrong? This is not being shared, is it? No. I apologize for my technical difficulties. This is totally going wrong. There we go. Share my screen. Start the broadcast. 1, 0, boom, sharing screen. Biggity bam. And there it goes, it caught up. All right, takes 2. So first, we're doing this example problem. You guys get the benefit that I've now written everything in first period, so it'll go a little bit easier and faster this time around. So hopefully that works out okay. So here's the first example problem. We'll do this one, then you guys have an opportunity to do a problem that's very similar. All right. So our context for this problem here is in a study of heart surgery, one issue was the effect of drugs called beta blockers on the pulse rate of patients during surgery. The available subjects were divided at random into 2 groups of 30 patients each. As is already noted here, the 30 patients each, that becomes the value of N1 and N2. And that's not doing what I want it to do. Why is this not catching up? There it is. All right, so those are some variables we need. Awesome, we know what they are. We actually have the same size samples for each population. That's a good thing. All right, one group received a beta blocker. The other group received a placebo. The pulse rate of each patient at a critical point during the operation was recorded. The treatment group had a mean pulse rate of 65.2. That becomes X bar 1, and a standard deviation of 7.8. That is S sub 1. Right? For the control group, the mean pulse rate was 70.3 x bar sub 2, the sample mean, right? And the standard deviation, 8.3, right, was S sub 2. All right, so we have all of our sample statistics here. We know what the sample sizes are. And before we move on to part A, which you guys can all see what part A is, what is this? Is this like a survey and a collection of data, or is this an experiment? Based on the context, what type of situation do we have? What type of situation do we have here? If you look at what I just highlighted, what does that say? It says treatment group. The only type of scenario that we have that gets treatments is experiments. All right. We want to know that context because it changes one of the conditions that we have to check when we check our 3 conditions. Right. This is a study in which we are not randomly selecting the people to participate in this thing. Right. We had available subjects and they were randomly assigned treatments. Right. That becomes important. I'll highlight that again later. All right. So part A, find the standard error. Standard error is essentially the standard deviation from our sample. Right? If we had all the population values, we would just be finding the standard deviation. But we call it the standard error in this case because it's from sample statistics for the difference in mean pulse rate between the 2 groups. So first here we have just what the formula is, right? Which I'll highlight and it'll pop up on your screen here momentarily at the front of the classroom. Put on the shared screen. There, boom, there it is. That is just the formula. That's the thing that will apply whenever we're finding the standard error. That's SE, standard error between these 2 sample sampling proportion. Sample means I'm getting all my words messed up right now. I apologize. The standard error of the difference of the sample means. There we go. That's what I meant to say. So we have the square root and everything here is under the square root. Please be careful on how you write this. If you make a teeny tiny square root sign and you have all these fractions and things on there, the person reading it is going to think that that square root only applies to what it covers. Make it big, make it cover everything. Show the reader, right, especially the AP graders, that you know what this thing is. You're using it properly, right? So we get the variance from sample 1 divided by the sample size from sample 1 plus the variance of sample 2 divided by the sample size of sample 2. Remember, this thing here, S squared, is variance, not standard deviation. And this is lagging on me today. The shared screen is updated and there that one is. All right, that is variance. All we do is square the standard deviation to get that number. Right, so we'll take the 7.8 and the 8.3, square it. That's the value in the numerator. There's no special calculation. We just have to square the value they gave us. All right, so then we get square root of 7.8 squared divided by 30 plus 8.3 squared divided by 30. And ultimately we get 2.08 as the standard error. This is awesome. This is good news. We'll use this later when constructing a confidence interval, which is the next thing we're asked to do. We need that standard error. That's what we multiply by our critical value. All right. Is there anything I can clarify so far? Sweet. Then we go to part B. Right, part B is asking us to construct and interpret a 99% confidence interval for the difference in mean pulse rates. When we see construct and interpret, that means 4 steps. State, plan, do, conclude. Right? And again, The 4 steps are there to keep you organized and to make sure you show everything you're expected to show. Okay? So part 1, state. What are we going to be doing? Well, we want to estimate with 99% confidence the difference in mu sub 1 minus mu sub 2, where mu 1 is the true mean pulse rate of patients similar to those in the experiment who take beta blockers, and mu 2 is equal to the true mean pulse rate of patients similar to those not taking beta blockers or they're taking the placebo. All right, notice the wording is very particular here. We can only apply results to patients similar to the ones who participated in the study. This does not apply to the larger population or the population in general, because these people were just who was available. It is not a random sampling of people participating in the study. Okay, so we can only make conclusions about those similar to the ones who participated. That comes back again later. Right, then we must plan. All right, and we get, here we go, our plan. If conditions are met, we will use a 2-sample T interval for mu1 minus mu2. If this was having to do with proportions, we would be doing a 2-sample Z interval for P1 minus P2. But this is mean, so we're using T, the T distribution. Table B, right? Check our 3 conditions. Random. The 2 groups are randomly assigned to the treatment. That meets our random criteria. Even though they weren't randomly selected from the population, the treatment was randomly assigned. We have the random condition, right? And again, this is because we're dealing with an experiment. If we were dealing with like a survey, a data survey, where we're just collecting the data, and we're sampling people at random, the randomness is that we took an SRS. We had a simple random sample. This is a different case. Now notice the 10% condition. Since we are not sampling, we did not take a random sample, and we did not sample from the population in general. We didn't sample without replacement. This condition is not needed. It does not apply to this scenario. Lastly, the normal/large sample condition. Both sample sizes are at least 30. They're exactly 30, but that still is enough. So the normal condition is met. And all 3 of our conditions have been satisfied. Well, 2 of them. The 3rd one didn't really matter. So we can now continue using T procedures, which is what we specified up top, 2-sample T interval. Is there anything I can clarify about this part of the process? I need to move things around a bit. Give me a second. That's better. Okay. All right. Sorry, April, I missed your comment earlier. Thank you. All right. So we've done statement. We've done our plan. Now we're going to do some math. All right. So here we go. The first part again here is just the formula we're using. And that should highlight here in a moment. Maybe if it wants to cooperate. There it goes. That's just the formula again, right? It is the difference of the 2 means from the sample plus or minus the critical value T star times the standard error, right? This is the same general formula that we actually use constructing any confidence interval, right? We have our sample statistic. In this case, it's the difference of the means plus or minus the critical value times the standard error. That's whether we're doing proportions or means. What we use for those changes depending on proportions or means, all right? We find the 99% confidence interval using table B with degrees of freedom equaling 29. And we will, on the shared screen here, look at table B. So if you're on your computer, I'm not able to put this on the projector at the moment, but if you look at the shared screen here, we're looking at table B, all right? And we get 99% down at the bottom there. And 29 degrees of freedom is actually available on the left-hand margin. If we follow this over, the intersection between 99% and 29 degrees of freedom is 2.756. Again, that becomes the critical value. And so that's where that number came from. Then we do our calculation. We get 65.2 minus 70.3 plus or minus 2.756 times 2.08. The 2.08 is just the result that we found in part A of this question. We already calculated the standard error. Right? And that is equal to negative 5.1 plus or minus 5.73. Okay? And that ultimately gives us this interval, negative 10.64 to 0.44. Again, as I believe I stressed yesterday, always list the smaller value first. The negative number is the smaller value here. 0.44 is the larger value. List the smaller one first in your interval. So we've done the math. Sweet. Are there any questions on the math, on the do step here? So then lastly, we get to our conclusion here. In our conclusion, we are 99% confident that the interval from negative 10.64 to 0.44 captures the true difference in the mean pulse rates of patients receiving beta blockers during surgery and those who take a placebo. There you go. That's our conclusion. We have now constructed and interpreted our confidence interval. And so then that brings us to the next couple pieces here of our problem. Right, we do have parts C and D. Which I need to use the scroll bar. That works. All right, so part C. Suppose we want to test the hypothesis that beta blockers reduce mean pulse rate. Right? If we're assuming it reduces, we're looking for a smaller pulse rate. State the null and alternative hypotheses for this test. Well, we get the null hypothesis, mu1 minus mu2 is equal to 0. No difference. They're the same. The alternative is that there is a difference, and that when we subtract these two things, because mu1 represents the people getting beta blockers, that value should be smaller than mu2. So when you subtract them, you get a number less than 0. So we get mu1 minus mu2 is less than 0 as the alternative, showing a reduction in pulse rate. Right. So these are the null and alternative hypothesis for this test. Right. We've already defined mu1 and mu2 earlier in the same problem, so we can use them again here without redefining them. Lastly, the test statistic. So they've done the math for us. They're not asking us to do the whole test. They're just giving us this value. The test statistic is t equals negative 2.453. Determine the p-value and draw an appropriate conclusion using alpha equals 0.05. So just to show the process here, we will continue to use the degrees of freedom of 29. Right? And we end up getting a p-value that is between 0.01 and 0.02. Now, I'm going to direct you to look at the shared screen real quick so you can see table B again. And we get this by finding in the 29 degrees of freedom, we find the value closest to 2.453. Because remember, table B does not contain negative values. We just use the positive value of whatever number we get. So even though this is a negative 2.453, we will find positive 2.453, or as close as we can get. And so positive 2.453 lies somewhere between 2.15 and 2.462 on table B. Okay, we're not going to land directly on it in this case, which means that that's how we get the interval, or the p-value, top and bottom range, so to say, is 0.01 to 0.02, right, using table B. We could get a more specific answer using our calculators, but we don't necessarily need to. This is we know that it's between these two values, which we absolutely know that that is going to be less than alpha, because 0.02 is less than 0.05. I'm going to switch back. Right. So then we have that our p-value here is less than alpha equaling 0.05. Since the p-value is less than alpha equals 0.05, we reject the null hypothesis. Right? We have convincing evidence that beta blockers reduce mean pulse rate among patients similar to those in the experiment. So again, we need to add that little part at the end that says among patients similar to those in the experiment, because that's the only group of people we can make a conclusion about, because that's where our subjects came from, people similar to those. Right, so when we perform this inference, we have to keep that as part of our context. Okay. All right. Are there any questions? Is there anything I can clarify about this example? Okay. So, going to stop sharing that screen. And we're going to look at the problem that I'd like you guys to work on, which means go here. So I'm going to share my screen again. I'm going to need you guys to go into Canvas to go to the next part of this here. All right, so now everyone should be able to see Canvas here. So please go to the modules. Sorry, I guess I'll switch this to student view so it looks like what you guys see. All right, in the chapter 10 module, we're going to be doing the 10.2 in class practice. It is categorized as an assignment. This is your participation for today. I do not expect you to complete all of this, but I expect you to get it started and then submit whatever you've got, basically. Whether that's one part of it done, two parts of it done, part of it started, that's cool. All right, and I'll reiterate that at the end. So we'll click into this, and the problem is right here. All right. So after I've done the example, which I just did, right, we're going to solve the following problem. I want you to do your work on paper and then upload a picture of what you've done, whatever that is. Right? If you're here in person, you do not have paper, I have paper right back there by the hand sanitizer, and I can give you a pencil that you can keep forever and ever if you do not have a pencil. If you did not bring your calculator, I suggest using the Desmos calculator on whatever browser you're using, right? Because that will allow you to type in the math that you want, kind of the way that it looks, and it'll just spit out the answer. It's going to be a little easier to get the answers properly done over using your phone. All right, so I have that suggestion for you. So again, I really want you guys to start, just do some pencil and paper work, you know, do the math, and practice in that way. All right, make sure to identify all necessary methods, parameters, and conditions. You should always be using the 4-step process: state, plan, do, conclude to perform any inference. All right, I also have in this assignment here, you have the 10.2 study guide, similar to the one that you saw yesterday for 10.1. And again, I have a link to the formula sheet and tables. And then we have the question. This question has basically the same 4 parts that the one like the one I just did, right? We have parts A, B, and C. We're going to find the standard error, construct and interpret a 99% confidence interval. All right, we're going to write what the hypotheses would be for this scenario if we're doing a significance test, and then we're given a t-statistic, find the p-value, and make a conclusion. All right, so that is what we will be working on. All right, everybody. That's 20 minutes. As I said when we started, I don't expect you to have finished all of this. That is okay. We're learning it. If you got part of it done, awesome. If you got part of it done, awesome. If you are still just looking through the resources and trying to figure out formulas and look at examples, awesome. That's all part of the process here. So what I would like you to do is whatever you have done, submit it in the assignment area. If you've done work, hopefully if you did work on paper, just take a picture of it, upload the picture, totally good. If you didn't get any work done and you were looking at resources and taking notes of your own, just type that in the text entry. I was doing research and taking notes. Like, that's totally okay. All right. I don't expect you to have whizzed through all of this stuff. I just wanted you to start, and I wanted you to think about it, and I wanted you to feel what 20 minutes felt like. All right. And that'll be your participation. Whether you finished it, whether you didn't, whatever you submit, it shows that you submitted something, you'll get credit. There's no partial credit here. You get all the credit. All right. So that will essentially be it for today. Next week, I want to do a little bit more with chapter 10. There's a couple of things I haven't quite shown you what I want to about it yet before moving on. So one of the days next week will be about chapter 10, and one of the days is going to be about AP testing stuff and making sure we're getting ready for that properly as we're getting closer and closer to that testing date. All right. So that's what's coming up for next week. Other than that, as usual, if you do have any questions, comments, concerns, please reach out to me. Let me know. While you're here in person, when you are here in person, that's a great time to ask for help and support during like asynchronous time. And other than that, I hope you guys have a great rest of your day, and we will see you next week.